we'll start today the chapter armature reaction. Am I audible?
Yes, sir.
Okay. So we'll start the chapter armature reaction today. As I told you in the last class. Okay, so before going into the armature reaction, so we have to draw a few things. So that means distribution, MMF and flux distribution in space. Okay, so this is very important thing. So though I have discussed this a little in some earlier classes, or maybe in the classes of fundamentals of electrical engineering. So let us draw uh, a typical DC machine. Okay, and having two poles only. Simplicity, I am considering only two poles. Okay, okay. Now these are the poles. Now let me assume some winding, which are basically concentric winding because their centers are same. So this is the central axis for the pole, and we have taken some concentric winding for the poles. Okay, so let me consider these are the dot. These conductors are carrying dot polarity current, and these are the cross currents. Same for this, the dots, and these are cross. Okay, now sometimes this axis we called direct axis, and the axis which is in perpendicular, sometimes it is we called it quadrature axis, so q axis. So two axis, direct axis and quadrature axis or q axis. Okay, now as per the given current direction, you just tell me that in which direction the flux will flow.
From lower mm, pole to upper pole actually,
Bottom to top.
because upper pole will be
You are
south
saying
pole. Yes, sir.
bottom to top.
Bottom to top.
Okay, so
Yes,
that
sir.
means let me draw these lines. So these are the flux lines, and As per the convention, the flux lines here will flow from bottom to top. Now let me ask somebody else. Let me ask Himadri Das. Himadri Das, Himadri Das. When I'm calling somebody, try to unmute yourself immediately. Otherwise, I will mark absent. Okay. Let me ask then. Nirmallo Nondi. Nirmallo Nondi.
Yes, sir.
Now you
Hello.
just tell me if this is
Hello,
the.
sir.
I can hear you clearly. Now you just tell me if I assume this is the direction of the flux lines, then which pole should I call south and which pole should I call north?
স্যার আরেকবার বলবেন। হ্যালো।
হ্যাঁ, শুনতে পাওনি? আমি বলছি এই যে আমি
হ্যাঁ
ফ্লাক্স
স্যার
লাইন্স
আরেকবার
গুলো
বলুন। ফ্লাক্স।
এই যে ফ্লাক্স লাইন্স গুলো দেখিয়েছি,
হ্যাঁ
so
হ্যাঁ
according to these flux lines,
হ্যাঁ
which pole, here you have two poles. Now according to this flux lines, which pole should be called as north pole and which pole should be called as south pole? So that is my question.
হ্যালো স্যার,
Hmm.
লোয়ার পোল।
কি?
স্যার লোয়ার পোলটা নর্থ পোল।
The bottom one is north
হ্যাঁ স্যার।
and the upper one is south. So is it okay? অরিত্র মজুমদার, অরিত্র মজুমদার,
ইয়েস স্যার।
ওকে
Yes,
ঠিক
sir.
বলেছে?
ইয়েস স্যার।
Okay, so that means this is the correct north pole and south pole. So if these are the north pole and south pole, then if I want to draw the distribution, so that means how would I draw the distribution? What I will do, suppose let me mark some points like these points at this axis is A. Okay, so this is suppose this axis is B, this is C, and this is D. So what I will do, I will move clockwise. So clockwise I will move from A to B, B to C, C to D, D to A. So in this way I will move. Where I will move? I will move through this air gap. Air gap means, which is the air gap? Air gap is this. So this is my uh, line of movement. So this way I am moving. So I am moving in this direction. Okay, so have you understood this? I am moving in this way. Now you just tell me that what MMF distribution would I experience? What kind of MMF distribution would I experience? So that I will plot here. Whatever you will tell me, I will plot here. With respect to the space angle, because when I am moving in a circular direction, that means what is changing? The theta, the angular displacement is getting changed. Okay, and I will first plot the MMF. Okay. Now you just try to
Sir,
understand what
MMF
kind of MMF should I get. Suppose
sir,
this is my A point. Let
MMF
me
should
draw
be
first. Bolo.
sir, MMF should be rectangular. I think
Huh.
that means between the point
Okay.
B
Can you
and
draw
D,
it? Can you just try to
the
draw
MMF
it?
constant.
You just try to draw it. All. I am asking all to draw this MMF. And I will randomly I will ask you to show your sheet. You just try to draw the MMF. I'm asking all to draw it. This is very important thing. If you don't understand this thing, then many things you won't understand. Is it over? It's very simple. You don't have to think that much because you know already you have the magnetic circuits and all you have already studied in basic electrical engineering or maybe in some earlier classes. Rishabh Mahajan, Rishabh Mahajan,
Yes, sir.
have you drawn it?
Sir, I need some more time.
You need some more time. Ruflekha Rai,
Yes, sir.
have you drawn it?
Hello. Sir, I'm drawing it.
Sushmit Rudro, unmute. Have you drawn it?
Yes, sir.
So can you show?
Yes, sir, I can show. So just a moment.
Okay, so I think it is not correct because first you have taken here this kind of distribution you will get for 4 poles, but now you have only 2 poles. So that is the first mistake you have done. And the second thing is it will be rectangular distribution, not like not flat top sign. Okay, so you just switch off your video. Somebody else who have completed. Who? Devraj? Devraj Banerjee? No.
Yes, sir, done.
Ayon Query. Have you drawn it?
Yes, sir.
Okay, so you just show. Yes. So I think this is the correct one. This is the correct one. And the sign also he has taken correctly. The positive and negative sign. Okay, so you see just around this B, because B comes just under the south pole, so therefore positive MMF, and D comes under the uh, north pole, so it is as per the convention, positive convention of flux and MMF, so it is negative, so it is correct. Okay, so thank you. You just switch off your video. So that means what he has drawn. So it's a rectangular distribution. Okay, so if I extend it theta, then somewhere here you will have another A. Somewhere here you will have another A. So this is how it will look like. The distribution of MMF due to the pole only. Okay, for south pole it is positive, and how far it will be extended? It will be extended only up to this. Only up to this. Wherever you have the coil, so it will extend it up to this length. So this length is basically this length, and here this length is basically this length. So is that clear? Okay, and if you want to know that what is the value of this MMF, then it is very easy. So if the field current is IF, same for the other one, because the same current will flow through these two field coils because they are connected in series. So if this is field current is IF, and if the number of turns around each pole core is N, or you can also write the NF. So NF IF will be the MMF. So this is your NF IF, and the opposite one will be minus NF IF. So is it clear? Now, if this is the MMF, now I will ask you to draw the flux distribution. This is the MMF distribution. MMF is the cause, remember, and the flux and MMF. Flux is the effect, which not only depend on this MMF, it also depends on the reluctance. Okay, now you just try to draw quickly the flux distribution due to this. The flux distribution due to this quickly. From the next class, I will give you some number which will contribute your internal marks to this. Whoever will show me correct answer will get some marks for this. quick flux distribution. The flux distribution for only for this MMF, which I have already drawn.
Sir, I have a doubt regarding this MMF distribution.
Who?
Sir, Pushpal Banerjee.
বলো।
স্যার এর আগে যখন আমরা একটা ফ্লাক্স ডিস্ট্রিবিউশন ড্র করেছিলাম যেটা ওই
হুম,
ফ্ল্যাট টপ
হুম,
সাইনোসয়েডাল টাইপের হয়েছিল,
হুম,
তো তখন তো আমরা মানে এটা করেছিলাম যে ফ্লাক্সটা দুম করে কমে যায় না, এটা গ্র্যাজুয়ালি আস্তে আস্তে কমে তারপর আবার একটা জায়গায় কনস্ট্যান্ট থাকে।
হুম।
তো এই এমএমএফটা এমনি চেঞ্জ হচ্ছে, তো এমএমএফটা অ্যাকচুয়ালি আমরা যদি ফর্মুলা ওয়াইজ যাই তাহলে তো ফাই ইনটু রিলাক্টেন্স হয়। তো আমরা যে এবিসিডি তে ঘুরছি,
No, no,
তো
MMA is the
তো
cause.
এটা
MMA
কি
equals to phi to reluctance is okay, but MMF is the clause, then your reluctance will be modified. Okay. So MMF is the cause, and that will exist if there is some current and number of turns. Basically, MMF depends on the currents and number of turns. Wherever you have the current and number of turns, then there only you have the MMF. Okay, exactly যেখানে যেখানে যত অবধি এই কন্ডাক্টরটা রয়েছে ততদূর তোমার এমএমএফটা থাকবে। Okay, now the reluctance is not uniform, so therefore the flux will be different, the flux distribution will be different, as the reluctance is not uniform. Not only reluctance, there are other effects which is called the fringing effect, flux fringing effect or end effect. So due to all this, the flux distribution will be a little different from this MMF distribution, but MMF distribution will be this rectangular distribution.
ওকে স্যার, তো আমরা প্রত্যেকবার এমএমএফ থেকে ফ্লাক্সে যাব, ফ্লাক্স
MMF থেকে ফ্লাক্সে যাব,
কখনো এমএমএফ
ফ্লাক্স থেকে MMF এ যেতে পারবে না এই কারণে, তার কারণ হচ্ছে রিলাক্টেন্সটা, এক্সাক্ট রিলাক্টেন্সের ডিস্ট্রিবিউশনটাও তুমি জানো না, আর উল্টো দিকে হয়ে
না
যাচ্ছে
স্যার।
ব্যাপারটা, বুঝতে পেরেছো? রিলাক্টেন্সটাও তো ভ্যারি
হ্যাঁ
করছে,
হ্যাঁ হ্যাঁ স্যার, হ্যাঁ স্যার।
সেটাই হচ্ছে অসুবিধা।
ওকে স্যার।
Have you drawn it? Who has drawn it? Who has completed it?
Yes, sir.
Who? Swarnadeep?
Yes, sir.
Have you completed?
Yes, sir.
Just show it. Just a minute. Okay, it's correct. Only you should draw the MMF and the flux in the same curve so that we can correlate. Okay, it's correct. It's correct one.
Okay, sir.
Okay.
Okay, sir. Okay.
So that means what he has drawn, though these two scale are completely different. So this is for one pole, and for another pole, it will be like this. You can draw better than me because I am drawing in a different platform. So this is the flux distribution. Okay, so flux distribution for the main field. And this is the MMF distribution for the main field. Okay, now the next I will draw, I will ask you different thing, that is, suppose in DC machine, you know that we have not only this conductor or this winding, we have another winding which is placed on the rotor like this. Okay. So what is the difference in these two winding? Can you tell me? The
Can you please
winding
repeat the question?
in a DC machine, we have one winding which is wound around the pole core. So another winding we have which is wound or which is rather placed on the rotor, which is placed on the rotor. Okay. Now what is the difference between these two windings?
Sir, that winding the pole winding is responsible for the generation of magnetic flux, whereas the winding in the rotor just
But
is used to rotate the
winding cannot generate the flux. Do you agree this? Winding cannot
current
generate the
through the
flux. The
winding.
current through the winding can generate the flux. I am asking the difference between the windings when the machine is unexcited. Okay, both the coils are unexcited. Then what is the difference? That means what is the difference in their construction? So that is my question. Have you got it? কেউ বলবে ডিফারেন্সটা কি?
Sir,
হ্যাঁ, কি জসিমউদ্দিন?
the input flux will be positive. No, sir, Manjur.
হ্যাঁ বলো।
Sir, input flux will be positive.
Input flux will be positive means?
The N-pole.
হ্যাঁ।
The direction of flux will be changed.
Again, I am asking the difference between the windings. That means when they are unexcited, when there is no flux. Your point is correct. That convention will change. এখানে যেখান
Yes,
থেকে
sir.
ফ্লাক্সটা বেরোচ্ছে সেটাকে আমরা পজিটিভ ধরি, স্টেটারের ক্ষেত্রে সেটাকে নেগেটিভ ধরি, সেই জন্য নর্থ পোলটা নেগেটিভ দিচ্ছে। তোমার পয়েন্টটা কারেক্ট, কিন্তু আমি সেটা জিজ্ঞেস করিনি। আমি জিজ্ঞেস করেছি যে এই দুটো ওয়াইন্ডিং, one winding I have shown for the field, another winding I have shown for the rotor or armature. So what is the basic difference of between these two windings?
Sir,
হুম,
field
বলো।
winding coaxially wounded হয় আর armature winding টা radially।
কাছাকাছি, ঠিক হচ্ছে না। আর আর কেউ? রেডিয়ালি ঠিক নয়। আমি একটু আগে একটা টার্ম ইউজ করেছি, that concentric. For field winding, the winding is concentric. It's a concentric coil or concentric winding. That means here the center for all this conductor, the center is same. But here you see the centers are different. For suppose if you take this coil, so the center is this. If you take this coil, the next coil, the center will be different. There will be some angle between these two. Are you getting? কি বলছি বুঝতে পেরেছো? Suppose if I take this coil, then the center will be this. If I take this coil, then the center will be this. The center, sorry, not the center, the axis. Their axis will be different. Isn't it? কি বুঝতে পারছো?
Yes, sir, yes, sir.
সব কয়েলগুলোর কি অ্যাক্সিস সেম থাকছে? In case of rotor winding?
No, sir.
So therefore, this type of winding is called the distributed winding. এত দেরিতেও সব আসছে জয়েন করছে কেন বুঝতে পারছি না। What is the problem?
স্যার ক্লাসটা অ্যাকচুয়ালি 7টা থেকে ছিল।
হ্যাঁ, but you have already informed না? ক্লাসটা তো 7টা থেকে ছিল জানি।
স্যার অনেকে হয়তো স্যার অনেকে হয়তো পাইনি ইনফরমেশনটা।
Okay. So now it is already 7. So this is called the distributed winding. So the distributed winding we use for the rotor in case of DC machine. Distributed and concentric. So this type of winding. Can you tell me that concentric winding is also used for another machine or another device? Which is that?
Port type transfer.
Transformer.
Transformer.
Or all transformer use concentric winding, not distributed winding. Okay. For all transformer, not only code type, shell type, any kind of transformer, we use only concentric winding, where the axis is same. Okay, now I will ask you that if I have this distributed winding placed on the rotor, and if there is some current in this conductor, distributed conductor, like this. First, I will ask you that as a motor, in which direction it should rotate? As a motor, in which direction it should rotate? Quick, তাড়াতাড়ি বলো।
Sir, anti-clockwise.
Is it so? Hmm?
Yes, sir. From the left-hand rule, if we apply the left-hand rule,
Hmm.
then it will move to clockwise, anti-clockwise.
Okay. So you are saying that it will rotate in this direction as a motor, isn't it? You all verify
sir.
this, whatever he told. I think it is correct.
Yes, sir. Yes, sir.
Okay, so it is correct, I think. Now, as a generator, then it will rotate in the opposite direction. It is always true. For a given current direction, if the motor direction is this, then the generator direction will be just opposite. Okay. Now, you just think that the distributed winding here, which is placed on the rotor, is only carrying the current, not the field winding. Are you getting? I am asking you that here you think only the distributed winding which is placed on the rotor is only carrying the current, not the field winding. Then what will be the MMF pattern and what will be the flux pattern? So that thing I have to draw in the same curve. You just try to draw it. Okay, I think you will have some problem to understand this. What I will do that I will give you some picture on this. Okay, suppose let us take just a minute. Okay, so let us take these two. One is this, another is this. So let me mark it. These two. Let us take these two coil only. But that means these two conductor. And let me draw somewhere here. Suppose I have one dot, another cross. Okay, just like which we have told for this concentric winding. Suppose this is also a concentric winding. Think about this concentric winding. Then what will be the MMF? One dot, another cross. কি হবে বলো? If this is a concentric winding,
পজিটিভ এমএমএফ হবে
একটা পজিটিভ এমএমএফ হবে, তাই না? যেরকম ভাবে আমরা একটু আগে আঁকলাম, যেটা সাউথ পোলের জন্য হলো, একই হবে। Okay, now let us take another. Suppose these two conductor. What will be the MMF? Again, that is positive. If I draw some line here, so it will be another positive, the same value. Now, if I overlap these two, then what will be the net MMF? Net MMF will be this. Here it will be doubled because here you have the contribution for two coils. Here you have contribution of one coil, but here you have contribution of two coils. So therefore, the value of the MMF will be just doubled. So is that clear? বুঝতে পেরেছো এটা? For the next,
স্যার দ্যাট মিন দ্যাট সাইডের গুলো কি হবে?
সব হবে, সবগুলো নেব আমি।
স্যার দ্যাট
কোন সাইডে গুলো? কোন সাইডে গুলো বলছো? So if I take the third one, if I take,
ওগুলো তো যেরকম ছিল সেরকমই থাকবে, কারণ উপরে তো অ্যাডিশনের কিছু নেই।
if I take 3, then one more step I will get. If I take 3, then one more step I will get.
হবে মানে ডিস্ট্রিবিউশন।
হ্যাঁ বলো।
স্যার তার মানে তো এটা স্টেপ ফাংশন হচ্ছে এমএমএফ ডিস্ট্রিবিউশন।
হ্যাঁ,
এমএমএফ টা স্টেপ
হ্যাঁ।
ফাংশন হিসেবে কাজ করে।
Step function হবে।
আচ্ছা আচ্ছা।
Okay, so that means this half portion will give me a step. So let me use a different color. Okay, so this half portion will give me a step, or rather like this. Okay, and another half portion, that is the white portion, will give me another step in this side. Are you getting? Okay, are you getting? So that means here we have the C, and another, that is, it is giving the maximum peak at the quadrature axis. Here you have the A. This C and A, this C and this A. So one staircase will have its peak at C. Another staircase will have a bottom peak at A. Is that clear? এটা বুঝতে পারছো সবাই?
Yes,
So
sir.
if I draw it more finer step, the same C and A, if I take more finer step, so how it will look like? It will look like this. এখানে আমি একটু তাড়াতাড়ি আঁকছি. You can draw it better way. So it will be look like this. And we can approximate this with a triangular waveform. মানে এই কয়েল গুলো যদি, কন্ডাক্টর গুলো যদি খুব কাছাকাছি হতো, তাহলে এই স্টেপের সাইজ গুলো খুব মানে ছোট ছোট হতো। And it can be approximated with a linear curve or triangular curve. So that means in case of distributed binding, so always we'll get some sort of triangular distribution. Okay, so this I am drawing for distributed winding. And what kind of excitation? Here we have only DC. So DC excitation. So is it clear? Remember, I am drawing only the MMF. So this is my MMF curve, not flux. Don't confuse these two. Repeatedly, I am just warning you that don't confuse with the MMF and flux. This is the MMF, not flux. Flux will be different. Flux depends on the reluctance, not only MMF only. Is it clear? If it is clear, then I will show
Sir.
it. বলো
স্যার বলছিলাম সিটা কেন পজিটিভ হবে আর এটা কেন নেগেটিভ হবে, এটা একটু আপনি বলবেন?
that is as per the convention.
ও আচ্ছা,
Flux at the MMF positive MMF convention. বুঝতে পেরেছো? আর কিছু না, কনভেনশনটা উল্টে দিলে এটা উল্টো হবে।
ওকে স্যার।
Okay. Now let me draw it here. Very difficult to draw the straight line over here. Okay, so that means if this is the quadrature axis, that means you have one thing you have understood, that one curve has its peak at d-axis, another, so this is also d-axis, but the armature or the rotor winding has its peaks at quadrature axis, isn't it? And it has it has passing through 0.
স্যার
বলো শুনছি।
স্যার
বলো শুনছি।
বি আর ডি পজিশন যদি দুটো কনজিকিউটিভ, হ্যাঁ বি আর ডি পজিশন দুটো কনজিকিউটিভ স্লটে যদি ডিস্ট্রিবিউটেড থাকে তাহলে সেক্ষেত্রে কিরকম হবে?
বি আর বুঝলাম না কি বলছো।
ডি বি আর ডি পয়েন্ট যদি কনজিকিউটিভ দুটো স্লটে ডিস্ট্রিবিউটেড থাকে তাহলে ট্রানজিশনটা কিরকম হবে জিরো জিরো অ্যাচিভ করবার সময়?
বি আর ডি পয়েন্ট
হুম
বি আর ডি পয়েন্ট তো
বি আর ডি পজিশন
বি আর ডি পজিশন দুটো স্লটে হবে, এটা তো পুরো অপোজিট ডিরেকশনে আছে। আমি বুঝতে পারছি না তোমার কোশ্চেন দেখি। বিটা তো তোমার সাউথ পোলের আন্ডারে
মানে
আর
বি
ডিটা নর্থ
পজিশন
পোলের আন্ডারে।
যদি, হ্যাঁ বি পজিশন আর ডি পজিশন যদি স্যার দুটো কনজিকিউটিভ স্লটে ডিস্ট্রিবিউটেড থাকে
হ্যাঁ তাতে কি হবে বলো, কি জানতে
তাহলে
চাইছো?
ওখানে ট্রানজিশনটা কিরকম হবে?
কোন ট্রানজিশনটা?
বোঝাতে পারছি না স্যার বোধহয়।
না
মানে
তুমি তো বোঝাতে পারছো না বলতে।
সি আর ডি তে ম্যাক্সিমাম ভ্যালু অ্যাচিভ করছে মানে।
হ্যাঁ তাহলে এখানে সি আর ডি এর মাঝখানে সি আর ডি এর তোমার সি থেকে এ, তো সি থেকে এর মাঝখানে তাহলে এখানে
হ্যাঁ
ডি
স্যার
আছে।
সি আর এ তে ম্যাক্সিমাম,
এখানে ডি আছে। এখানে ডি আছে। হ্যাঁ আর এদিকে তোমার এখানে একটা বি আছে আর এদিকে একটা বি আছে।
ডি তে যদি একটাই স্লট,
একটা স্লট হলে একবার হবে, একটা স্টেপ হবে।
স্যার বি আর ডি তে যদি একটাই স্লট না,
একটা স্লট হলে একটা স্টেপ
আর
হবে।
দুটো স্লট হলে মানে লিনিয়ারলি যেরকম,
কোনো লিনিয়ারলি কখনোই হবে না, আমি এটা
আর
অ্যাপ্রক্সিমেট
দুটো
করেছি।
স্লটে যদি ডিস্ট্রিবিউটেড থাকে ওটাই জিজ্ঞেস করছি।
দুটো থাকলে দুটো স্টেপ হবে, তিনটে থাকলে তিনটে স্টেপ হবে। এবার তোমার নাম্বার অফ স্টেপ যত বাড়বে তত এটা ট্রায়াঙ্গুলারের দিকে অ্যাপ্রোচ করবে। If you have infinite number of slots, then it will be perfect triangle.
আচ্ছা আচ্ছা ঠিক আছে।
Okay, if it is not that, if it is discrete steps, you will get as simple as that. বুঝতে পেরেছো? মানে কোনোটাই তো মানে এক্সাক্ট ট্রায়াঙ্গেল কোনোটাই হবে না, আমি জাস্ট অ্যাপ্রক্সিমেট করে দেখিয়েছি বোঝার সুবিধার জন্য। Okay, so that means the MMF which we'll draw here will reach its peak at this C, and if it is D point, this is your B point, this is your D point, and this is your A point. Okay, so it is again passes through this D. Eta exactly holo na. Okay, so D like this. So again it will go like this, it will go like this. So have you understood this MMF distribution? So this we call MMF of armature. The previous one was MMF for field, and this is the MMF for armature. Now I will ask you very important question. Listen carefully. If this is the MMF, then what should be the flux? What will be the flux?
Same by reluctance.
But I want the nature. Phi F.
Actually, at the tips of yes, phi A.
So for
So
that you need
actually
this
at the
figure.
tips of the
This figure you need. Suppose I am moving from A to B, B to C, C to D, D to A. So Now you have maximum at A and C. Now MMF determines the flux, but reluctance also have some role.
So will it be a negative cos distribution?
Not exactly.
Sir, peaks will be
Exactly.
curved downward
Why?
because
Will
the
you-
reluctances are most at the places where the MMF is maximum. That means at point A and C, the
Correct. Correct. Why
reluctance is
reluctance is
maximum also.
maximum? You see these gaps. Here the gaps are very small.
Yes, sir.
Here the gaps are very small. So therefore here the reluctance is almost uniform, not only uniform, and that is the least reluctance you can get in this path. When you are moving from A to B, B to C, C to D, D to A, in this whole path, you will come across the minimum reluctance path only under the poles. And rest of the places, especially in the quadrature axis, in this Q axis, the maximum reluctance you will get. Maximum reluctance, isn't it? So we'll get the maximum reluctance. Now for armature flux, for armature MMF, though the armature MMF reaches its peaks at A and C, but there you have the maximum reluctance. That means you will not have the very high flux in this quadrature axis because of this high reluctance of the maximum reluctance. So therefore what he has told that it will be curved down at that position. So that means here you will have a low flux like this. মানে যত দূর পোলটা রয়েছে তত দূর এটা ভালো একটা ফ্লাক্স দেবে, কিন্তু ওর কাছে এসেই এরম কমে যাবে because here you have the high reluctance. যত তুমি পোল থেকে দূরে সরে যাবে তত তোমার রিলাক্টেন্স বাড়তে থাকবে। So this is the flux due to the armature. So have you got this point? Now if you want to see that where you have the pole, basically you have the pole where you have the pole up to this, including the pole shoe, you have the pole up to this. এইটুকুনি পোল আছে, একটা পোল যেটা নর্থ পোল, আর একটা পোল আছে এখান থেকে একটু এক্সটেন্ড হবে এখান থেকে এইটুখানি, এইটা একটা পোল। So these two are the two poles. এই দুটো জায়গা জুড়ে পোল আছে, দুটো থিকনেস সেম হবে কিন্তু আমার ছবিতে একটুখানি ডিফার করেছে। ওকে, সো if this is the south pole and this is the north pole, সেই জন্যই এই মাঝখানটাতে in this region the reluctance is very high. Here also you have the reluctance very high. Here also the reluctance is very high. So therefore this curves has a bottom in this position, in this quadrature axis position. So have you understood this?
Yes, sir.
So
স্যার
these two,
একটা ডাউট
হ্যাঁ বলো
আছে স্যার।
বলো।
স্যার এই যে ফাই এর যে কার্ভটা আপনি এঁকেছেন এখানে ম্যাক্সিমাম ফ্লাক্সটা ঠিক কোন পয়েন্টে আসবে?
সেটা তো সেটা এক্স্যাক্টলি বলা যাবে না, that depends on the how much distance is there between these two poles. পোল শু, বুঝতে পেরেছো? মানে ম্যাক্সিমামটা আসা উচিত হচ্ছে জাস্ট আফটার দ্য টিপ, আফটার দিস টিপ, মানে সামহার হিয়ার ইউ উইল গেট দ্য ম্যাক্সিমাম। জাস্ট আফটার দিস পোল টিপ ইউ উইল গেট দ্য ম্যাক্সিমাম। মানে তুমি কোন পয়েন্টটা জিজ্ঞেস করছো? এই পয়েন্টটা কি? এই পয়েন্টটা জিজ্ঞেস করছো তো?
হ্যাঁ হ্যাঁ স্যার, এই পয়েন্ট।
হ্যাঁ, এই পয়েন্টটা হচ্ছে জাস্ট পোল টিপটা পেরিয়েই ম্যাক্সিমাম,
হ্যাঁ।
ম্যাক্সিমামটা আসা উচিত। তারপর থেকে ডাউন শুরু হবে।
আচ্ছা আচ্ছা, ঠিক আছে, ওকে।
সেই জন্য তো আমি এই জাস্ট এইটার পরেই দেখো এটা এঁকেছি। Any other doubt? So you just try to understand these things clearly, and I will share the video because this will be required. This MMF distribution not only will be required only for DC machine. This MMF distribution will be required for any machine. So I will tell you how it will be required for all the machines. So next day we'll discuss the armature reaction. So to understand the armature reaction for DC machine, these things are very important. Okay. So thank you very much. So I will stop the share, and I have a